Birds do it. Bees do it. All of us animals do it. Let's do it. Let's move around. Come on. Let's go.
Bill?
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Bill Nye the Science Guy is brought to you by feet, moving animals for a really long time.
You and I are animals. We move. Now, all of us animals have to move to survive. We move by walking on the ground. Some animals move by flying through the air. Other animals move by swimming through the water they live in.
I'm a little horse.
Some animals slither along the ground. Other animals have other ways of moving along the ground. Now, all of us animals move around, and it's part of what we call animal locomotion. Animals moving. Now, animals like us humans move by pushing on the ground. Other animals push on the water. Some animals push on the air. See, there's all different ways to move, all different types of locomotion. Oh yeah, fish swim through the water. Some fish fly through the air. Birds fly through the air. Birds swim through the water. Some animals live on the ground. Other mammals live in the water and swim. Some mammals fly through the air. And insects live in the air and on the ground and in the water. There's so many different types of animals that move around in so many different ways. So many different types of animal locomotion. But we've all got one thing in common. We move to survive, to find food, and to find a place to live. If we couldn't move, well, we wouldn't be around anymore.
Time for great moments in locomotion. The millipede walks by coordinating the movement of its 200 legs. It looks like piano keys when you run your fingers along them. We've got to tune this millipede.
Animals move around by pushing on things. And when they push, they pull. Please consider the following. Animals like us move around by pulling on things with our muscles. You see, our muscles can only get shorter. They can only squeeze together. We say they contract.
All muscles have the same function, to contract.
And take a look at this. This is Terry the plastic skeleton.
Hello.
And we've rigged her up with some rubber muscles.
Muscles don't push, they only pull.
If her arm goes like this muscle's getting tighter. It's contracting. And this muscle is stretching. It's getting looser. And if her arm goes like this, these muscles get shorter. And this muscle hardly does anything at all. That's how she pushes or pulls, by making muscles get shorter. This is true of a lot of animals. Now take a look at this. Here's a cat skeleton. So when the cat runs or jumps, it pushes down like this with its foot. When that happens, this muscle gets shorter. It's pulling. See? So the only reason the bone sticks back here this far is so that when this muscle pulls, the foot goes down. Now, animals like fish move by squeezing muscles on this side of its body and letting muscles on the other side go loose. See? Like squeeze, loose, loose, squeeze. See? Like that. And then it could swim. Tighter, looser. Looser, tighter. There. And this one also squeaks. A lot of animals move by squeezing their whole bodies. Animals like squid and octopus. They work kind of like this. Here's a water balloon, and it's squeezing on the water inside it. Then if we let one end open up into the sea, the balloon shoots right off, see? That's how real squid move through the ocean. They squeeze their bodies and make a jet of water. See, this is a rubber squeeze toy, too. Yeah, it works. See, these animals all move by squeezing. Well, thank you for joining me on Consider the Following. It's not bad.
If you're an animal, in some ways, you're a living piece of meat. Sometimes other animals will try to mess with you and maybe try to get a bite. But some animals need to avoid getting eaten, so they run away. Yeah, it's an old trick, but if you can outrun who or whatever's trying to eat you, you have a better shot at survival.
And when a sea urchin is pursued by a helmet conch, the strange chase has all the qualities of a nightmare. Swinging from side to side, the huge mollusk inches forward on its muscular foot. Oblivious to the sharp spines, the giant snail rears over its victim. It will soon cut its way.
Try this. Try moving around without using your feet. Try it for a half hour.
I'm Melissa Hines. I'm a veterinary scientist, and this is Homer, who's a thoroughbred, one of the breeds most commonly used in racing. We've devised a way, using a treadmill, to watch the way they move more closely. It can tell us how long their stride is and how much force is being generated. We also study how things that we do, like using special shoes or trimming their foot, can affect these things so that we can prevent injuries. For a 1,000-pound animal, horses actually have very delicate legs. The hoof, which is the part he walks on, is actually just like walking on the very tips of your fingers. The horse's gait can vary from the walk, where he has 3 feet on the ground at one time, all the way to the gallop. When they gallop, we found out that for a fraction of a second, they're actually suspended in air or almost flying. Then they go through another fraction of a second where all of their weight is on just one leg, generating a tremendous amount of force, at least twice the weight of the horse. One thing that's unique about horses is that when they gallop, their locomotion and breathing are linked. This means that they take a breath with every step, and at high rates of speed, they may breathe over 100 times a minute. We recognize that animals move in different ways. The way horses live in the wild has made them tremendous athletes. But even within horses, different individuals have different abilities. Some are better endurance athletes, while others are sprinters. What a good boy.
Yeah, it's a great big world out there, and animals have found all kinds of ways of moving around in it. Now, whether you use fins, wings, or feet, all animal locomotion involves pushing off of something. Now, if you don't use fins, wings, or feet, well, then you need scoots. Snakes have to move around to find food. I mean, they're animals. But they don't move around the way you and I do. Snakes scoot. And they scoot using scoots. Now, scoots are special scales on a snake's belly that only slide in one direction. So, by wiggling different parts of their bodies at different times, snakes can scoot along the ground. They can even climb trees. Now, there's other animals that move like this, like worms. But instead of scales, worms have tiny hairs on them that only let them move in one direction. So the hairs dig into the soil, and the worms can wiggle their way forward. Now, slugs wiggle along too, but they don't use scales or hairs. They use their whole stomach. In fact, slugs are gastropods, and gastropod means stomach foot. So a slug's whole foot is its stomach. Its whole stomach is its foot. And it wiggles it in just the right way so it can move along anywhere it wants to go. See, these animals move along fine. I mean, they're never paralyzed by self-doubt. Paralyzed by self-doubt. I mean, they don't wonder what they're going to do next. They just go and do it. Not very fast, but they do it.
The earthworm moves by crawling. Special muscles lengthen and shorten the body in wave-like motions, while 4 pair of tiny hard bristles in each segment help it grip the ground and hold onto the side of the burrow.
Water skimmers. On the surface of water, molecules stick together and form a thin liquid like skin we call surface tension. Surface tension. Surface tension. Surface tension. Surface tension.
All right already!
Water skimmers are so light that the surface tension holds them up. Bend the paperclip and see how it works. The wire is light enough to sit on the surface of the water, just like water skimmers. It's science, and it's cool.
Animals have different sized feet. Animals have different sized feet. Animals have different sized feet, so that they can move around in different ways. You can make your own model of an animal print using plaster of Paris, which you can buy at any craft or hardware store. Mix it up and find an animal print. Like this one right here. Now pour the plaster in. And come back later when it's dry. Check it out. You've got an animal print. I think it's a dog, yeah? Cool.
Fish swim, but they're not the only ones. And some insects swim too. Insects like the water beetle have legs that act like the oars on a rowboat. Alligators swim by swishing their powerful tails. Now, whales swim too, but they're not fish. Whale tails go up and down, whereas fish tails go back and forth. Now, some birds swim too. Birds like ducks have webbed feet that allow them to push against the water. Animals like these sea otters have webbed feet too, because they live in the water, and their bodies are shaped like fish. Their hair is slick and smooth, so they can slip through the water easily. See, if you're going to live in the water, there's no otter way to do it. No otter way. I think they thought it was funny.
This is another Great Moments in Locomotion. The walking catfish can move over land from one body of water to another. Able to breathe out of water, it pushes itself along the ground with its tail. Whoa!
These are sea stars, and they move around with feet on their arms. Each arm has hundreds of tiny suction cup feet. So by tensing and relaxing muscles in its arms, sea stars can make the suction cups stick to things. And then by moving their arms and operating the suction cups, sea stars can go wherever they want. Now, you know, some people call them starfish, but not really fish, so we call them sea stars. And sea stars smell with their feet, too.
Clams have 1 foot, but they move just fine. Here, look. It's sort of like this rope anchor. First, a clam sticks its foot out in front of itself like this. Then blood flows towards the foot, making it swell, anchoring it to the sand. Then the clam pulls itself towards its foot. Clams move like this to find food and hide from predators. I move like this for a total body workout. It's pretty fun. You should try it.
He said, try it!
some animals move in ways that are kind of cool. Like, take the inchworm. See, it anchors its head and then pulls its back end up to meet it. Then it moves its head again and then pulls its back end up. See? Head, back end, head, back end, head, back end, head, back end, head, back end. And then they inch along. And if you've ever seen an inchworm, they're only about that big. So maybe we should call it a half-centimeter worm. No, that name's too long. It's an inchworm. And it uses its whole body to move around, to find food and a place to hang out. Not bad.
Lions, tigers, and cats use their tails for running. The tail helps them aim their body. It helps them steer. They can hunt other animals that are slower. They also use their tails when they fall or jump. The tail helps them land feet first and keep their balance.
Spiders don't move the way you and I do. No, they use their hearts to pump their legs full of blood. So their legs straighten out when they move. And then they pull themselves up to that leg and straighten it out again. See if I can show you. I don't know this tarantula. See if I can just not spook him. Big TV spook, see? So they move by straightening their legs out.
Bill? Bill?
Sorry, Arlo, sorry.
We are experiencing technical difficulties. Please stand.
Spiders don't move the way we do. No, they use their hearts. And they pump their legs full of blood, make them straighten out, and then pull themselves up to that part of their leg. See how they straighten their legs out?
This is Great Moments in Locomotion. The Speed Walker moves quickly over the ground using strenuous heel-toe movements in strict adherence to the rules of the International Race Walking Association, and can reach speeds of up to 15 kilometers per hour. Hey, watch out for that.
Bumblebees look too big to fly. Especially this one. Now, how do they do it? Well, bumblebees have strong flying muscles in their midsections, what we call their thorax. And when the muscles pull tight, their wings go up, and when they relax, their wings go down. But there's a lot more to it than that. It turns out that a bee's thorax acts like a big spring. And when she pulls her muscles tight, her thorax squeezes together like this. And then when she lets go, her thorax relaxes and her wings go up and down about 40 times. About 40 beats for every squeezing of her thorax muscles, her flying muscles. That's how bees can go forward or backward or hover or anywhere they want. It's beautiful.
Here's a way to see how footprints can tell you things about who and what made them.
We're going to be doing this with butcher paper and paint.
'Cause it's messy.
Yeah.
Nicely done. Now I'll step into the blue paint and run.
Yellow. Hopping paint.
Now I'm gonna do my feet and hands. And if you do a comparison, it's pretty easy to see the different kinds of prints go with different kinds of moving.
Animals move around. They locomote by pushing on things.
Come on,
they can't move anywhere unless they give something a push.
Come on, quit
like
that.
Like the land, the sea, or the air. See, it's a big...
Billy, sure, please don't do that!
Locomotion, we move in different ways. Flying, swimming, running too. We're in motion, we go from place to place. To survive, we gotta move. There was a bird flying high, a mole digging low, a fish swimming round. Animals move in so many ways. There's one thing I have found. It's locomotion. Animals are all in motion on the land and even in the ocean, where they swim around or in the open sky they may be found. Animals move to find prey or maybe just to escape. Animals move in so many ways, they go from place to place. It's locomotion. Animals are all in motion on the land and even in the ocean, where they swim around or in the open sky they may be found.
Well, that's our show. Thanks for watching. If you'll excuse me, I've got some synaptic vesicle action potentials to measure.
Association with the National Science Foundation.
These things are alive. Turn that thing the other way. No, I can't do it.
Beautiful. Her whole thorax beat about 40 times. But there's more to it than that. Each arm has hundreds of tiny feet on it, and each foot is a suction cup. So by relaxing and tightening muscles in their arm, sea stars can pull water up into the suction cups.
Yakety 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 yak. Yakety 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 yak.